geometry notes for lesson 1.2, points, lines, and planes notes. I have some important vocabulary up here. So the term description is a point. This at one point was highlighted. It's kind of hard to see. A point indicates a location and has no size. You can represent it by putting a dot and a capital letter, such as this is point A. So you can just draw the point and the letter A, and you would call it point A. A line is represented by a straight path that extends in two opposite directions without end and has no thickness. These are kind of self-explanatory. I'm sure you guys know what a line is, but there are certain ways to label it that are really important. So here is a line. It has 2 points on the line, one point A and one point B, and it also, this is a cursive letter L. I know it looks like an E, but for some reason in math they always use a cursive letter L as also a line, probably because it starts with an L. So you can name a line by any 2 points on the line, such as line AB. This is read line AB, so that's just how you pronounce it, but you would write it like this, line AB. Please be sure you do have arrows on both ends. That's the thing that signifies that it is a line. Or you can read it going the other direction, line BA. And both of these are correct. Lines could go this way or this way. They extend in both directions forever, so it doesn't matter. The other way you can name it is if there is a little letter L up here, or any letter, you can just call the whole thing line L by writing out the word line L. And it doesn't have, you don't have to write it in cursive. You can write it like this, line L. I just happened to do the same letter, or the same looking L. All right, let's keep going. A plane is represented by a flat surface that extends without end and has no thickness. So it's hard to see with this box, but actually think of it as this box, this plane continues out in all directions. It goes every direction and has no thickness, and it's extending out. It's usually drawn in kind of a rhombus looking shape, but actually it represents a plane that continues in all directions infinitely. It contains infinitely many lines also. So within this, there are infinitely many lines. If I were to draw in lines, there'd be infinite lines all through the plane, and they would continue in each direction because that's what lines do. The way you name a plane is by a capital letter that's usually up in one corner. So right now I see a P with no dot next to it, and that's because it's not point A, point B, point C. This is not, sorry, those are points. This one's not a point. It's just a letter up there in the corner of the rhombus. So that means they're labeling it as plane P, and you can call it plane P. Or you can also name it by at least 3 points on the plane that don't all lie on the same line. So if there was a line within this plane and it had 3 points on it, like FGH, you could not call it plane FGH. If you said plane FGH, this would be wrong because they would all be lying on the same line. In order to name a plane, either name it with the letter that's in the corner or name it with 3 points that are on it that are not all 3 in the same line. 2 could be in the same line, but the third one cannot. So it can be called plane ABC. Okay, quick review of parallel lines. I know you learned about these in algebra, but parallel lines are 2 or more lines within the same plane that do not and will not intersect. So 2 lines that would be equally distant apart from each other and would both lie on the same plane would be parallel lines. Okay, skew, I don't think you guys talked about skew in algebra, but they are 2 or more lines that lie in different planes and do not and will not intersect. So a lot of people think, oh, it would be just one line going this way and one line going this way. However, if this one at some point would intersect, these would not be considered skew. So what we're talking about here is we're talking about either a line in one plane and a line in another plane that it's really hard for me to draw 3-dimensionally. In fact, I'm going to try to show you with this box that's going to come later in your notes. this line would be skew with this line because they will never intersect. See how this one, you can see it better three-dimensionally here. This one is going to go up and down forever, and this one goes left and right forever, but they're in two separate planes, so therefore they will also never intersect. I hope that makes sense. These two lines would be called skew. Okay, so this was a terrible job. However, I hope that you understand it better after looking at that. Okay, let's go to your second page of notes. It's going to start at the top, and it's going to just basically be going ahead and giving you some practice. So let's see if you could do this before you get to your actual homework practice. Name 3 line segments. Okay, we didn't really talk about segments yet. So, oh, you know why? It's because I skipped a page. I'm so sorry. Okay, here we go. Here's a segment. A segment is a part of a line that consists of 2 endpoints. So it's almost like a line, except guess what? It doesn't have arrows at both ends, meaning it stops. So you can read it this way or this way. So it could be line segment AB or line segment BA. But what you will notice is I did not put arrows on the ends like I did here when it was a line. So this signifies that it's just a segment. Okay, another important definition is array. Array is part of a line that consists of one endpoint and all the points of the line on the one side of the endpoint. So it's exactly how it looks here. There's an endpoint on one, but it continues going on forever in the other direction. This one is a little tricky to name. This one can only be named ray AB. You can't call it BA because you always read the part that starts with the point and read to the part that goes on forever. I also want you to know that if this were, for example, going this direction and this was CD, even though you call it CD because you go from the point to the one that goes on forever, you still write it with the arrow going to the right. So rays are always written like this. You just put the letter that comes first as wherever your end point was. I hope that makes sense. Okay, opposite rays. So opposite rays are 2 rays that actually share the same endpoint, and they form a line. So what we're talking about here is if you start at C, you could go this direction as a ray, or you could go this direction as a ray. So these are 2 going opposite directions. If you think of them as going opposite directions, those are opposite rays. So these rays, because you could call this your end point, this would be ray CA, and this other one would be ray CB. Okay, and I know this doesn't look like a ray. This looks like a line. This actually is line AB, or line AC, or line CB. You can name this several different ways as a line, but if we look at it starting from point C going opposite directions, that's where the rays come in. All right, this one is really hard to see because the shading wasn't too great. So what we're looking at is this section right here, if you can't see it as good. All right, what they want to know is I want you to name the shaded section. So since there are not arrows on both ends, this is a segment. It's a line segment. And so we would call it segment EF, or you could also call it segment FE. Both of these are correct, and you don't have to write both, just one or the other is fine. Okay, this shaded part actually does have an arrow at the end. Again, it's kind of hard to see, but they meant to shade this whole thing with the arrow at the end here. So this one could be called, it's definitely a ray because it has an end point and it definitely has an arrow at the other end. So it's for sure going to be a ray. But if you started here, it would be ray DF. Or if you started here and really only wanted to tell me that it also was a ray this direction, you could also call it ray DE. And again, the reason is because since it's a ray, this goes on and on forever, this one end. So it doesn't stop here, but this is the same ray as this because this line continues to go on forever. Okay, now we're going to get to that third page. I was jumping the gun there. Sorry about that. Okay, so that's why it's number 3. We weren't ready for number 3 before, but now we are. Name 3 line segments. So, I mean, really, you could just pick whichever chunk of this you want. So let's just start with this first little chunk in here, DE. So since it's a line segment, it's just a bar above it, and I'm going to put DE. Another one is from E to F. So you could call that segment EF. And then the last one is if you went from the beginning to the end, so segment DF. Some students in the past have had questions. They're like, well, why are you calling these segments? If there's arrows on both ends, they look like lines. They are, but if we want to name 3 specific line segments, then we're going to say we're just looking at the shaded region from here to here. We're just looking at the shaded region from here to here. Or we're just looking at the shaded region from here to here. I know it's a line, but if I call it a segment, I'm only talking about the specific part of the line. Okay, name 4 rays. Well, they're all going to be arrows to the right because that's how you always write a ray. But let's see what we've got here. If you started at this end point and went to the right, that is ray DE. If you started at D and went all the way to here, that would be ray DF. Let's say we wanted to start with E and just go to here. That would be ray EF. Let's say we wanted to start at F and go the other direction. You know, this arrow points this direction too. Rays could go this direction. So maybe we want to start at F and go all the way to D. So FD. I know it says name 4, but I'm just going to keep going because there's a couple more I see, and I just want you guys to be really clear in your notes. So we could have started at E and gone this direction. So ED. And then I think there should be one more. Which one have I not said? FE. From F to E also. So FE. Okay, those are 6 possibilities, but you only had to name 4. Any of these would work. Okay, name a pair of opposite rays. Opposite rays, there's only 2 choices because we've only got one that's in the center. So since E is in the center, you're going to be talking about your opposite ray going that way from E and your opposite ray going that way from E. So what we've got as far as opposite rays are ED and EF. All right, what are 3 other ways to name RQ? And by the way, you have to look really close, but this is actually line RQ. It's got those tiny little arrows that you can barely tell are arrows at the end. I'm sorry it didn't copy very big, but that is line RQ. So what are 3 other ways to name RQ, line RQ? So first of all, let's go over here to this picture and look at where line RQ is. They're talking about this line right here with arrows on both ends. So this line. What are 3 other ways to name it? Well, you can name it any of the points on the line. So we could name it line RS because S is also on that point, or on that line, sorry. So line RS, that's one way to name it. We could also name it line QS because Q and S are still also on that same line that we're talking about. So line QS. And then the other way I see is, once again, they've done that silly little cursive letter L to signify this particular line. So we're going to call it line L. And those are my 3 ways right there that you can name that line. All right, number 7. What are 3 other ways to name M? So let's go look at M. Oh, this is line M. So we're talking about this line now. What are 3 other ways to name line M? So I see 3 points on that same line that we're talking about that's line M. There's T, Q, and N. So you could start with just this little part and name it line TQ. You could do the second half and do this part, line QN. And by the way, you can go the other direction too, line NQ, doesn't matter, line NQ. Direction doesn't matter because they extend in both directions forever. And then maybe I want to include T and N. So line TN or NT, doesn't matter. The direction again does not matter. Okay, here's a new vocab word for you, collinear. It's exactly what it sounds like. If it's collinear, then that means it's on the same line. So if it helps you to go ahead and define this real quick, on the same line. Collinear means it's on the same line. So what point is collinear with points N and Q? So let's go look at points N and Q and see what other point is on the same line, is collinear, and it would be point T. So you name it either point T or you can call it point T like that. Either way. All right. The next question says, list all points that lie on plane P, or just P. I just knew it was plane P because it's marked over here in the corner, and a lot of planes are marked with the letter P just because it stands for that. It doesn't actually have to be a P, but a lot of times it will be. So list all the points that lie on plane P as shown in the diagram. Okay, this is really hard to tell because it's not three-dimensional. It'd be a lot easier to see if it was something like this, but I need you to see that these dashed lines means this line cuts through the top and then goes through like underneath it. So the only actual line that's on this plane is line RQ. This line cuts through it, but it is not actually on it. So list all points that lie on plane P as shown. So here are some points that are in the plane. R is in the plane. Q is in the plane. S is in the plane. And V, even though V is not on this line, it's still on the plane itself. So it's on that square, that kind of parallelogram plane here. All right, number 10, what point is non-coplanar? Okay, let's define non-coplanar. So real quick, just like collinear means on the same line, coplanar means on the same plane. So if this one is non-coplanar, that's going to be not in the same plane. Sometimes these vocab words are very self-explanatory if you kind of separate it apart. Not on the same plane. Okay, so what point is not on the same plane as P? Well, here's P. It's this parallelogram. So something that's not on there is T. T is way up here in space. And point N. N is way down here in space. So point T, or you can actually just write T, and N. I don't know why I didn't space that out, sorry. T and N. Okay, number 11. What are 4 unique ways to name the plane shown in the diagram? Okay, well, let's look. The whole plane can be named plane P. We've already talked about that. So we're going to say one way is to call it plane P. Another way you can name it, if you go back to our first page of notes, is you can name it with 3 points, as long as all 3 points are not on the same line. So let's go look. You could name it R, V, and Q. R and Q are on the same line, but V is not. It's okay for 2 points to be on the same line, as long as all 3 aren't. So I'm going to call it plane RQV. Plane RQV. Another way is let's find 3 more points. What about RVS? R and S are on the same line, but V is not, so that's okay. I'm going to call it plane RVS. Plane RVS. Okay, and then one more way. Let's look. How about QVS? I don't think we've used that yet. Q and S are on the same line, but V is not. So plane QVS. Okay, great. Let's go down and look at numbers 12 and 13 about this box that I kind of already drew on earlier, but that's okay. Each face of the box represents part of a plane. So again, these are planes. Pretend they continue out in space in all directions infinitely. It's just that we're seeing a section of it. So what would be the intersection, so where they meet, an intersection is a place where they meet, of plane ADC, let's figure out which one we're talking about, ADC, so we're talking about this top of the box. ADC is that plane, and plane BFG. So let's see which one BFG is. B, F, and G. This one is the side plane. So basically, if they're saying what is the intersection of two planes, the intersection of two planes is always an entire line. So it has to be a line, because if two planes intersect, it's not going to intersect at a point, it's going to intersect at an entire line. So this is line BC or line CB. So it is line, don't forget to put your arrows, and you can either call it BC or CB. Okay, what are the names of the two planes that intersect at line BF? So at line BF, let's go look at line BF. Where's line BF? Line BF is here. Okay, so if this is what we're looking at, what two planes intersect there? It's going to be this side one and this front one. So just pick 3 points that are on this plane. So I'm going to call it, I think last time they called it BFG. So I'm going to put plane BFG. And the other plane that intersects there is this front one that I have not shaded in, that's white. So we could call it BAE, we could call it BFE, we could call it AEF, doesn't matter. So pick 3 of those to name the plane. I'm going to name it plane AEF. Okay. Last 2 questions are about parallel and skew. So which lines are parallel to line BF? So let's look at line BF. Parallel means they're going in the same direction. They will never intersect. However, I think part of our definition, actually, let's go double check. To be parallel, they actually need to be within the same plane. So let's find 2 parallel lines that are within the same plane as line BF. So the only 2 that are parallel to line BF are this one, if you're talking about it being on this plane, so CG, line CG. And then this one over here, because technically the corner of this is parallel and in the same plane as this front one, which could be this one as well. So AE would also work. Line AE. Okay. All right, last one. Which lines are skew to AB? So let's look at AB. AB is this top line right here, right across the top. Skew, remember, has to be going a different direction. So if this one's going horizontally, it needs to be going vertically, but also will never intersect it. So this one in the back over here will never intersect it. So that is line CG. Let's see what else. There are some more skew lines to AB. The other one in the back, way over here, DH. DH. Let's see, there's some more. How about, what do you guys think about EH, line EH? It's actually going horizontally as well. This one is horizontal and this one is horizontal, but they're going in different directions and they will never intersect. So actually, EH is also skew to line AB. And then there's one more. Look at FG. It's kind of the same situation as EH over here. FG is also, I guess you could call it horizontal, but will never intersect it and is not parallel. So FG is also skew. Okay, and that is the end of your notes for 1.2.